This is URK 19CS1093 experiment number 6 Banker's algorithm. So this is the code. In this first we have to allocate a integer array max with size it is two-dimensional array with size 100, and then another integer two-dimensional array called alloc, then need, then await, then two integer variables n and r. Then these are the two functions: void input, show, call, and this is the main function call. And inside the main function we are initializing two integers I and j, and we are printing Banker's algorithm, and we are calling input function, show function, calculate function, and get character function. We are returning 0, and inside the void input function we are entering the number of process, and that is stored into the variable called n, and then resource instance is stored into the variable r, and the max matrix is entered, and using a for loop we are getting it where I equal to 0, I less than n, I plus plus, j equal to 0, j less than r, j plus plus, because it's two-dimensional array. Then we are printing the matrix max of I of j. Then we are printing under the allocation matrix. Again using a for loop we are printing the alloc two-dimensional matrix, and we are asking the user to enter the available resource. That is using a for loop we are printing the available resource of j. Then we are calling the function show. Inside that we are initializing two integers I, j, and then we are printing the process allocation max available, etc. using a for loop. Then we are printing I plus 1. Then using a for loop where j equal to 0, j less than r, j plus plus, we are printing allocation of I of j, and then we are printing j equal to 0, using a for loop j equal to 0, j less than r, j plus plus, and then we are printing maximum of I and of j. Then using an if condition we are checking whether I equal to 0. If that condition is true, then it will enter into this for loop j equal to 0, j less than r, j plus plus, and it will print available resources of j, and it will go inside the function. Next is cal function. Inside that integer variables finish array with size 100, then a temporary variable is there, then need two-dimensional array, then here flag is given as 1, then we are using k and cl equal to 0. And another one is to know the safe state, and an array integer called safe with size 100, then int I and j. Using a for loop I equal to 0, I less than n, I plus plus. Inside that finish of I equal to, we are initializing it as 0 to find the need matrix. To find the need matrix we are using this for loop. I equal to 0, I less than n, I plus plus, and for loop j equal to 0, j less than r, j plus plus. And to find the need matrix of I of j equal to, the calculation is max two-dimensional array minus allocation. Next, and he will print that. And using a while condition we are checking while if it is flag, then flag is equal to 0, for loop I equal to 0, I less than n, I plus plus, and inside that int will be in it, like int c will be initialized as 0, and then using another for loop j equal to 0, j less than r, j plus plus. Using if condition, finish of I equal to 0, and need of I of j is less than equal to available of j. If these two conditions are true, then then c variable will be incremented, and if c equal to r, then you'll go for the for loop k equal to 0, k less than r, k plus plus, and k of avail of k will be incremented with alloc of I of j. Then finish of I equal to 1, flag is equal to 1, printf, we are printing the I, and if using an if condition we are taking finish of I equal to 1. If this condition is true, then we'll initialize I equal to n. Then coming out of all the loops and all, we are taking another for loop I equal to 0, I less than n, I plus plus, and using an if condition, we are checking whether finish of I equal to 1. That is true, then CL will be incremented, else it will print I. Then coming out of it, if CL n equal to n, then the system is in safe state. Or else, if the condition is not true, then the processes are in a deadlock, the system is in unsafe state. So let's run the code. Say number of processes 3. This is 3. Then allocation matrix. So here P1, P2, P3 is given, and this is the safe sequence, and this shows that the system is in a safe state. Thank you.